and I've got a printed copy for you, if that floats your boat.
Would you like me to pass it out?
Yeah, just to whoever wants a copy.
Who would like a paper copy, please raise your hands.
Oh, excuse me, one more thing. Russell's on. Russell Dozier is with us today. Russell is retired physics instructor here at Texas State. And he did some physics training with us. Toby was with us.
I didn't recognize him because he didn't have a beard.
When he came in, was it 10 pounds?
I don't know if you
So I
want.
told him what we were doing today, and he said, I want to come play. I went downstairs and look for stuff that we use back in those to see what you might want to use today.
Okay, so today, we're gonna deviate from geology today, and we're gonna go into motion instruction. Now, I titled this lesson Emotional Rescue. 10 bonus points. You know why? You wanna sing?
Oh, I don't know that line. I just got the emotional part.
Where are they going? I thought you said emotional.
It's
Oh, emotion.
It's
I got it, yeah.
a tie on
I know.
emotional rescue. Anyway, I
I
don't
don't know.
sing.
See, I
Tim, who?
I just know the song.
Okay, who's this song? Okay.
I don't know who sings it. It's just one of those.
It's
the
Mick
Rolling
Jagger that
Stones.
sings
Yeah.
it. Oh my gosh.
Yes.
We need to have a cultural check. Anyway, so this is called emotional rescue. We're gonna move in, we're gonna look at a lesson that is gonna be awesome for you to integrate with math, science, and writing. So first, I'm gonna ask that you get in groups of 4, 3 or 4.
That works.
Honestly, if you want to get in groups of 2, that's awesome too, because the supply, I have plenty of supplies today,
Okay.
and it's kind of cool. It's kind of cool.
Never mind.
Okay,
Sorry.
so just keep that in mind, and you're gonna do some collaboration in just a minute. So sit with your groups, please. Okay, it looks like you're already there. All right. Step 1. And I wrote this week in a hazy, sleep-deprived mode, so we're gonna edit as we go along. Brought my little pen to edit, so y'all help me. Okay, individually, take a minute, I want you to look at that table showing a dog's position at different times. There's points A through H. Huh? Point A through H, time 0 seconds through 7 seconds, and the position in meters of the dog. Individually, and you're writing, what pattern do you see in the time column? What pattern do you see in the position column?
Let me show you something else.
And Tom get a piece of paper.
Sorry, I didn't. Miss Laura, would you like us to write?
Yes, as always, Melissa. Great question. We always write incomplete sentences. Starting with a capital letter.
Spending money on crap that you never use in the classroom.
Of course, you're able to do that. It's, kids have fun
We do.
if I have one,
If you can get it in.
That's very clever. Okay, now, as a group, Oh, well, I'm sorry, you're so right.
Can you move in a little bit? We need to get this car. Brandon.
Nobody's gonna die because of answers. Oh, no.
Finished it over.
Okay, I got
Okay, what pattern do you see in the time column?
I need to go back.
Brenda.
I
So
just wanted to
each
make
time
sure.
you multiply the
Missed it.
value
No,
of the
you haven't
time by
finished it.
5/10, you discover the value of the position in meters.
Okay. But what pattern do you see just in the time
Oh, just
column?
in times. Oh, I'm so sorry.
Rochelle.
Okay,
So the,
Oh, hang on, Rochelle.
the time is increasing at a proportional rate?
Okay,
1 second?
1 second. So there's 1 second between each point. Okay. What about the position column? What pattern do you notice about the position
so
column?
it's only the column.
Yes.
I'm going,
The
sorry.
pattern I see in the position column is that from point A to point E, it is increasing by 5/10 meters, and from point E to H, it is decreasing by 1 meter.
Okay, good. So Mary Lou found two patterns. She found an increase and then a decrease, right? Okay, so let's turn the page. As a group, I want you to discuss what the numbers tell you about the dog's motion. Discuss what the numbers in the position timetable tell you about this dog's motion. Now, a little hint, if that table is too much, you can draw a picture, you can make a number line, and walk the number line. Thank you very much.
You did say discuss, right? So we should-
Yes, you should be discussing.
So who's gonna open the floor for discussion?
I see that the dog is walking off.
But that means in your quiet voice, so no one, so I don't hear.
Or a ledge or something.
So, 7 seconds.
Oh, because it's positive, so that has to mean one direction. And then negative has to mean, so that's opposite, right?
Okay, so that's what you're seeing with the, when it begins to decrease in meters.
It can't reflect like a left turn or a right turn. Because it's missing.
And you got that, you came to that conclusion from what value? For the negative, okay.
Years since I've seen that.
I'm saving them for my classroom because they
Well,
have things.
Yeah. Can you move it this way?
It could be a hill or.
Because I'm teaching to
Well, I'm thinking, why do we get to position and not be able to just walk up?
I will be drawing, I guess I could draw those between 0, 0.
You know, I'm thinking like,
I'm like sitting there looking, I'm like, it's not what I wrote down, why is
dog
it?
is turning a ledge. It's
Yeah, no,
one
I think
meter.
it's not like this. All the way.
5 seconds.
See, that's why I like that, is this
I
now like,
can't put time.
because of the distance, you know, if you want to go positive, you have to go.
That's what I wrote this morning. For some reason, my picture drawing.
For not getting XY axis.
Yeah, because then the position.
Well, but the dog's coming back, so they're negative 1.
Yeah, they don't,
They don't
So, it's over and sign it as a video. Not one second.
And then a constant.
He starts at his dog bed, he gets up, he goes to the front door, and then he goes to his
So what
dog.
I'm saying, if you was going like up a hill or
This
something,
is just in
go
general.
like slowly. Right, I mean, take you down at a faster rate.
I mean, you can
So
see outside.
my story is that it was a
Right, so he walked,
and since it was a little rat,
then
the
He's
dog rested
going faster.
Because he's covering more distance.
So he's going faster, so he's
So you're basing the speed assumption on the distance or the position, like you said.
And then from every age, then one, he's got to go back, which makes.
Okay, on the sidebar, you see I've put some little notes here for you. So this arrow represents a double arrow, and this is how a scientist would indicate a velocity arrow. We use that arrow for velocity. And what that shows is two things. It shows the direction of the motion, and then as the arrow gets bigger, it shows the size of the motion or the magnitude. So the longer the arrow, the faster the object is moving. So that might help you in your drawings in just a bit. Okay, now, number 3. You've come together, you've discussed the motion of the dog. So in your head, you should have a picture of how this dog has been moving and what it's doing. Maybe you created a story to go along with how the dog is moving. So I want you to use the table that's given, and you are going to you're going to calculate the average velocity for each of these intervals. So from interval A to B, kind of offset this table for you. So you'll write the value of the difference in time and the difference in distance or position. The triangle is called a delta sign, and that means a change in x. This is a change in time. So x is position, t is time, and velocity is the change in distance over the change in time. Yes, use real numbers, okay? For real numbers. And if you need a little hint, you can turn to the next page if you get stuck.
Oh, excellent.
You can draw your line. And then the register still draws straight lines. Because
so your
Do you need some coffee?
inside sister sneeze chicken.
changing this is what so you're changing your x.
Yeah, but you, yeah.
Meters, so you're changing
You're not even my partner, why am I talking?
Is it time, am I understanding the time's gonna be constant? You did the same for every single
Change the distance of the
Yeah,
So that's minus time?
Marilyn, I don't know. Did your process download like that?
It's just something that so this
Well, I did, and I moved it back and it didn't.
That's okay.
Maybe,
divided by one.
It's distance divided by time.
I downloaded it, like whatever, and it's just altered. PDF would be.
Oh, good. That's a good idea.
Yes.
Sounds like I go.
Oh,
Delta T. I'm sorry, Delta T.
Okay, how did, okay, I'm not here, this, how did I come up with this picture?
Formula doesn't change.
Save as a PDF and release it.
Okay, okay.
I thought,
Wait, Mary Lou, are you asking about the formatting?
I was telling you about that.
Yeah, it's kind of listening.
Yeah,
I think
mine is fine, because I have to email myself the PDF. So I send it to my computer, because every time I do things, like PowerPoint or something else, I save as a PDF, and I send it to myself in an email, and in that
So,
email,
Dawn,
could you send me my Wi-Fi one?
Alexis is going to go to the computer, resave that file
I
as a
can just forward
PDF.
it to everybody.
Then do that, yes. Thank you, Mary Lou.
Yeah, because it's messing.
In the meantime, would anyone like a handout to record their data?
I guess I would.
Okay,
Yeah.
so what did you find? Yeah. Okay. So what units are you using? There's one.
Time. Meters per second.
Meters and seconds. This is, because this is speed, it should be meters per second. This should be changed. Or changed.
MPS would be the second meters per the distance.
Meter-
We in science, it's M/S.
Right, so it's one.
But that's for speed,
What's that?
Up there, it's
Yes.
Yes.
because velocity, speed, and direction.
Oh, distance.
Meters per second.
I'm waiting for the math person to finish to make sure.
But
That
it's
distance and speed is what.
distance over time, which is distance is
Sort of.
over time.
I wonder, is it absolute value? Or we
Speed
take a
has a
negative?
direction, how can you have a negative?
You can have a negative
So it's
on
gonna
a
be
graph.
one that's going back up to that. That's what she's on the velocity.
But this,
Velocity equals distance over time.
no.
No, he's trying to figure out how it's so right.
I'm trying to figure out how to answer it correctly. So you're saying, how can you have a negative speed if there's no direction?
I can imagine.
You can still write it in that, I don't understand. But it would be a positive speed still, how can you have a negative speed?
That's the point you need.
That's the
I see what
point.
you're saying.
Riddle me
but-
these three.
So what are you writing down here, so it's,
Okay,
and
so
it's
the
still a
time
change
is
of
constant.
one
I just always
meter.
do.
And even if it's not zero to one, you don't write it as
Just tell me
negative
the
one.
distance over time.
Oh,
So in, the F, position is going negative.
So there's
Why can't, why
So
can't
we're
velocity
on
be
positive
negative?
two.
Well, it
no, I'm
Change
just
has to go
saying, I'm
backwards,
saying
so
in here,
it's
zero to one is still
It's
changing
one.
one.
but the,
Because going, instead of
But
going
if you're
to
going
increase now,
from
decrease.
your original position,
That's why I asked you about the negative.
position
Oh.
and subtract your
From 1 to
original
0, that's a
position,
negative
if
one
your
value. And then from 0 to
original
negative
position.
zero.
It's still measuring, it's still measuring
But now-
the distance
Okay.
of, even if I'm
So
going
this is
backwards, I still change, one meter.
So if I still
Position,
take
it's
one,
not
negative 1 divided by 1 is a
It's
negative 1.
one position
that's what I'm.
from
oh
another
no,
position.
it is wrong.
And if your position is negative,
So now,
I had it right to
it
begin
shows
with.
that, again, for positive value, your difference is going to be positive.
But it's the opposite.
No, I'm not, I don't disagree with that, but
right? That's what
if you're talking about speed, then you're right, we're not talking about speed.
I understand what you're saying.
I write you down, so it's hopefully give us board what I said.
Like, all of y'all make me feel like this.
Quentin has some great points. Let's come back and look at this table. So I'm gonna put my work up here. So this right here is called a difference table. We're calling this a difference table because it shows the differences and the times and positions at different points. Can y'all see that okay? So the difference from point A to point B, the difference in position was did I do that backward? Oh, this is time. So time 2 minus the original time is 1 second. The position, my new position is 0.5 minus the original position is 0.5 meters per second. Remember, there's no naked numbers. You always put your units on there. Yes, sir, Toby.
Are we working on language?
We are.
Always.
So it would be 5/10. Thank you. Yes, ma'am?
Coupon.
Would you put a 0 in front? Okay.
Always was just a decimal so that you know it's point.
Okay, thank you. 0 and 5/10.
Excuse me, could we call attention to that again? So part of our project is to work on vocabulary that's proper for each discipline. So Toby said, are we talking sloppy language here? He said language.
Yes.
And so Laura corrected it from the science, what we say, to the proper math language. And that's important and you probably, if you're like me, you're not going to remember the math language first. You're going to say the science, but hopefully you're going to say, okay, in mathematics, we really should say it this way because that's the correct way. Ours is the shorthand way that's not actually correct mathematically.
And I want you to bring these things up because I'm learning just like y'all are. And so y'all, thank you both for bringing those up. So during the course of this lesson, since Browning is not here, we all are Browning and we all are correcting our language. So what would Browning say? Yes?
No, just how y'all said in science. Also, my kiddos, they listen to me apparently, because I'm always saying that it's 5/10, 5/10, 5/10. I have a library in my room for books, and it's not actually level 1 and 5/10s. It's actually level 1.5. And so whenever I was talking about the levels, they corrected me. Because I said 1 and level 1.1, and they're like, you mean 1/10, right? Okay, so then I had to go into the, remember, it's in math you use this, but in English and science, it all depends on how you're using it. If we're talking about an actual measurement, but I'm not talking about 1/10 of a book. We're just talking about a label. So they are listening. They catch me all the time.
You could get by with saying by 1.5 because that 0.5 means half a
Yes,
year,
for your
which is
pen.
5 months out of 10 months if you're on a 10-month school.
Right, but you couldn't say 0.1 or 1/10 because that would be.
That would be 1
essentially-
month.
Yes. But that would
1
be
year, 1 month.
But that would mean if you set this up as a fraction, you have 10 months out of the year and you don't.
But doesn't that go back to your units
I have to
label? So if you put the correct units label, then are you going to be alerted? Russell, you're saying
I'm
no?
gonna have to talk to my English.
Okay.
Okay. I'm gonna have to talk to my English teachers now
Well,
about
it's like our
this.
TEKS. We don't have TEKS 8 and 1100s.
Right.
We have TEKS 8.11.
Right.
So it's a label
I
versus
assumed that
a
English
number.
was a label as well, but I can check with my English teachers to find out. Good point.
Now,
It's everywhere because we were in Amanda's room yesterday and she talked about an inference in English. And I thought, that's not exactly what we mean in science. So, you know, these
It's
nuances.
hard to get your brain, yeah, wrapped
Yeah,
around
and,
it.
and think how confusing again to kids. And that's why we call this our dictionary, confusing language in math and science. Because, I mean, when you're speaking English, something, whatever, and you're saying inference, I automatically know what it's talking about. But if I'm in science classroom and they use the term inference, then I know that's a little bit different from how we use it in ELA. So we already have that background to be able to distinguish those nuances, but our children do not.
the math teacher that I work with on my team, we do integrate our curricula more than others do. And she does not say 5/10. She's a biochemist. She has a master's in biochemistry and then became a math teacher. She uses the science language rather than the math language. And so she doesn't correct me very often because I use the science language too, and that's her background, that's what she does. So we both struggle with using the proper math language because we both are scientists first, and that's the way we learn, so.
That's my phone, I'm sorry.
All right, so now we know the terms to use, and we're gonna continue with the what would Browning say, and share that out, okay? So on my velocity column, I have 0 and 5/10. Now, is it 0 and 5/10 or just 5/10? How do I say this? 5/10 meters per second. And it's the same velocity to point E. And then it looks like my dog starts moving backwards at -1 meters per second. Or the dog is moving at -1 meters per second, which tells me the dog's motion is in the opposite direction as he was going before. Now, Quentin brought up, and maybe Russell can help us, this is velocity, but it doesn't have a directional component here. But this is negative, meaning it's going backwards from the original direction. So is this speed or is this velocity? Velocity is speed with direction. So thoughts?
I'm waiting, because I saw your face back there, I'm waiting for your.
What do you think?
Well, because, I mean, I'm thinking of calculus, because I did this in my calculus class, and we talked about velocity and acceleration, and what, a negative or a positive means. And with velocity, when you have a negative velocity, it means you're moving toward the opposite direction that you're in. But with speed, your speed is always going to be positive, because even if you're going backwards, you still have a positive speed.
Right. Right. Do y'all understand that?
So like in your car, even if you're going reverse,
You're still going.
you're still going at positive speed.
So then in math with direction, you always have a positive direction. You can't walk backwards and take away direction. You still had movement. Okay.
Yes.
But so then are we, so, I got what she said, so it can't be speed because you can't have a negative speed.
Yeah.
But it can't be directional for
Well, that's what the
velocity
negative
because.
Why can't this be
The
direction?
negative tells you
Well, we
the
don't know if
direction
the
you're
dog is going literally straight and literally straight back. What if he went left?
Yeah, does that make a difference?
You'd have to go in a circle.
Unless it says, like Toby, we talked that he had to be going like on a linear.
But wait. This is change in position. It's not change in distance. It's change in position, which indicates, that's why the number line hint was there. Yes.
Are you, okay, when you say that it changes position, are you talking at that exact point at time 4 seconds? So each time second is an individual point. So when it goes to a negative direction, then from point to point, you're looking at that, I guess is what I'm trying to say. Where yeah, what's that?
Let me show you what I mean.
Okay.
Okay, so let me turn this around.
I thought of a dog walking on a ledge or a plank.
Okay, so
That's
here's
right.
our plank then, right? So here's our distance, 1, 2.
Scooch it down just a little. Thank you.
Perfect.
I'm gonna do this by 0.5 increments.
So may I ask a question?
Yes.
So since we're doing this like a number line, whenever your position is 1 meter, should it not have the exact same point value? Like point C is 1 meter and point F is 1 meter, like G? No, F? So instead of having an F, should it also be labeled point B as well, or no? I don't know.
So it's tracking the dog's motion by different points, not the point of labeling the motion is not labeled.
Okay, so it's not an actual position. So when they're at 1 meter, they're not exactly at the same location, they're just 1 meter from the starting location.
So the dog looks like, and this is not it, I'm not marking the time, but the dog looks like he goes from here to here, all the way to 2. So he goes here, and then he moves back to point 1. So this the first 4 to E, here, this occurs over 4 seconds. And then he turns around and he runs back, and this occurs over 3 seconds. Yes?
The velocity does show.
The word over, you said it a second time now, and I was wondering, in the sense that you used it to mean during,
During,
as
yes.
opposed to divided by.
Mm.
And one of the things that's always driven me nuts with my students, I tell them, little Joey lives in my head, and he jumps at those words. And the word over is ambiguous. Do you
Okay.
mean
To over
above,
during?
on top of?
Okay.
or Do you mean
During.
divide or during?
During, not a mathematical
Right.
term, so
And
we
so-
should use the word
yeah.
during. Okay.
And so, is velocity the change of position over the change of time?
Let's see, is that right?
Are we meaning in the over, are we meaning during? In which case, we're saying that the velocity is the change in position during that time?
Yes.
Or are
During
we
the
saying it's
change in
ratio,
time.
the division of two numbers?
It's when we're talking about division.
I don't use the word over unless I'm.
No, I actually set up the ratio and I say
4
10
over
over 5. I'm literally,
Confusing.
okay, so you would actually say 10 divided by 5.
Brownie would say 10 divided by 5.
Okay,
If she were here.
okay, she's gonna get this up and then have a new.
What's her number?
Actually, she couldn't get a sitter, and when I told her Russell was coming, she was upset we were gonna be using so much math today, but then when I told her Russell was coming, she was really upset she couldn't be here.
In
I
this,
suggested something like that.
in velocity is the change in distance divided by, could you use the term over?
I wouldn't,
Okay.
because my students have a tendency to, well, back
Is
when I
it
was
not a ratio
teaching them,
then?
have a
But if
tendency to
it
think
means
they
it's,
always had to have the change in position and the change in time as numbers before they could think about velocity.
okay, okay. So
Because
you have to
they
find the
didn't
numerical
understand
value and
velocity
then
met
divide.
this concept.
Okay,
I've always per unit.
okay, so it's divided by.
Or
Is the right way to say that, Ben?
per.
Could you say per unit?
Okay, I mean, because like there's, what are the synonyms for the fraction bar?
That's not really what you're trying to do. They did a very good job in here saying, calculate the average velocity. Yes. The concept.
Divide
called-
the position.
What should we call this concept? Should we give it a name before we teach what the concept is?
Should we give it a name? No.
I thought that was supposed to be built into you. Never, ever give it a name before you get the concept.
So don't say this is velocity and here's how we calculate it.
Yes.
Okay,
If we could find something like a number that represented the rate of change of the velocity,
so you're
that would be a
saying,
useful number.
so this right here changed to a number that represents the change in position divided by time?
No. I would call it the rate of change of position.
The rate of change of motion, okay.
Position.
Because isn't the, okay,
Motion.
question,
Laura.
Position, right? Okay.
when using rate of change, isn't that delta y over delta x?
That's how you calculate it.
So that's why you just
But my
use the word
speedometer-
rate of change.
But, yeah, that, I use it for the speedometer in my car.
Okay.
It
But
tells
that's
me
why
the
that-
rate of change of, if I had a compass on it too, then it would say position. But that's what it's measuring, is the rate of change at a certain time. We're trying to get them to think of this jargon word as having some meaning other than, how do I calculate it? How do I calculate it? How do I calculate it?
Okay,
Rate of change in position.
got that? Yes.
So I've heard position or
Yes.
Because distance is always
That's
possible.
when I was arguing.
Yes.
Possession
So-
is negative.
So we're talking about
Position.
Right.
Oh, well,
But people have been saying the delta X is the change in direction. I've heard that more.
When you do rate of change in
Yeah,
position.
it's not
So
the
it's
change
just
of
position.
direction, it's the change in position.
well, if we go to that, definition, velocity is a description of how fast an object is moving and in what direction.
Backwards is what it's, the direction is here. So our directions in this scenario are limited to forwards and backwards. Yes,
Now, the problem,
okay.
backwards. Is the dog moving backwards when he's moving in the negative direction? Is he walking backwards?
No.
His position
It could
is,
be.
So would you say we laid out?
He's walking forward, he's not doing a moonwalk, right?
Yeah.
That'd be cool, because then he would be facing one direction but moving.
So he's walking in the negative direction, or opposite direction.
That's what I said.
Walking, and first he's walking forward
Yeah.
in the opposite direction.
I've been teaching a long time, so I really see and students are
He's still going
opposite
positive.
has to have a reference.
conversation at a time.
The opposite has to have a reference. Opposite to what? Negative also has to have some reference. One direction is called the negative direction, the other direction opposite that is called the positive direction. We have a tendency to omit positive symbols in front of numbers, and we just assume it's positive. If I am walking north, am I walking in the positive direction?
In reference to what other position?
If I walk 50 meters, would it imply automatically that that was north?
No.
Or would it say north? But for some reason, with numbers, on a number line, we don't put the plus in front of the number.
This is a sixth grade concept, guys. Do you see how important the idea of position is to get to speed, velocity, and acceleration? And that's a well, actually, it's a K6. K5 is relative position. And I guess 6 would be position. I don't know, but it's more than it appears to be. And so if 8th grade is going, remember 8th, for those of you in elementary, for those of you in elementary, 6th grade, position and speed. In 8th grade, then it moves up to velocity and acceleration. So do you see how important it is for position to be taught correctly, extensively, foundationally at 6th grade? Because speed, velocity, and velocity and acceleration are critical for that foundation of position and speed. And that is not what we're seeing in 6th grade science.
This problem was set up wrong, because it did not give us direction to calculate velocity.
Okay.
So we would need to go back and restructure the beginning of the problem and say, okay, now we have an animal, dog, walking north with the different, points, times, and seconds. They needed to give us direction, so they set us up to try to answer the problem incorrectly.
Well, just
We can't do it.
Just because you're going north doesn't mean you're going, I can go east and still be going positive.
They didn't give us direction.
They gave us position.
Right, that's it, but no
Position
direction.
along a line, and if that's marked out, like you drew, you put the little line and the little mark the position. Once that's defined,
Then-
the directions naturally come from the numerical plus or minus.
Yeah,
In front and behind.
they didn't
It's
do
just
that.
a matter of what words we use when we describe those positions. Because they're just labels. I mean, like the A, B, C, D, the letters, those are just labels that say this, I guess you would say, here. This little dog, I wonder, little dog that can't speak English but knows the alphabet? So he can't say, I'm here, I'm here, I'm here, I'm here, but he can say A, B, C, D, in those different places.
So he's going
So
positive.
that you
He's
can have
going.
two different labels for the same place.
You can have two different. Okay. When he's going positive, you said forward. So how?
Forward?
That's what you said. So he was positive. You say the dog is walking. Okay. Then how would we correctly say positive to represent the positive change?
Put a little plus
Position.
symbol in front of it.
So he's moving in a positive direction.
Yes. So the direction we labeled positive.
And then if he's
Let me
going-
give
is
you
this
a
a
little bit of
negative
history
direction?
on this.
He's
Well,
going in
we
the
were
negative
used-
direction, the other way.
When we were using physics as our, rather than earth science, and Russell was teaching it, Tim and Toby probably remember, how many hours did we spend on position? Probably at least 4 hours on position. And the teachers were fussing to high heaven. They were sick of position. Oh, Tanya, yes,
It
right?
was 2 years of position because the first year our minds had melted. And then the second year we came back and Russell molded them the way that we needed.
Exactly, and actually Tanya was the one who asked for more instruction on position. But here's the story I was gonna tell. The next day, when we moved into speed, and they started using position as they understood it, except Tanya, and a few others, of course. They would say, now I get it. And then I fussed at him. I said, you fussing about having to spend so much time yesterday on position, and now you see why you need that foundation. So the bottom line of my story is, even though something seems simple to us, do not underestimate how profound that simple simple concept is, how foundational it is, and do not skip over it. I don't care if you're talking math or science. You cannot assume that people understand it. I mean, even, I don't think, well, I have to confess, I'm sure I did not understand position till I wrestled with it with Russell. And we had lesson planning time. So we were, I was with him then as well as during the instructional time. So if your 6th grade is not teaching position conceptually, and if K-5 is not teaching relative position in depth for them to understand it, then, I mean, they're not going to understand speed, velocity, acceleration.
So on the lower grade levels, needs to be much more concrete.
Every grade level needs to be much more concrete. And not dismiss it because it sounds simple. And it may sound simple because we understand it, but it also may sound simple because we don't understand it. We think we do, but we don't.
And like in 5th grade, it's based off forces, pushing and pulling. And you determine if it's a push from your position, and push and pull is towards the center. Pushes away, pulls toward the center.
So the question is, do we use positive and negative with
Pushing.
11-year-olds, 10-year-olds?
No.
Yeah.
5th grade teachers don't.
Okay,
Okay, I'm not
so-
suggesting an answer, I'm suggesting to think about it. And I think what I want to point to end up here is the kind of depth of thinking Toby revealed, and I'm sure others of you were doing it too, the kind of depth of thinking of a concept in a lesson, and does this activity actually teach the concept that it says it does, or we think it does, or does it not teach it correctly? And it's only that depth of content. Content isn't everything. It is foundational. It doesn't make any difference how clever you are, how good, strategies and cute activities that we have. If it does not teach the content, because the teacher doesn't know the content well enough, all that other stuff does not matter. Content is everything. It is the foundation. So, never give up on learning more content. Don't ever stop doing that. And ask each other these kind of hard questions when you're doing your lesson planning. Because if you don't understand that content correctly, you're not going to plan effective instruction. Tim was talking about using SIM, which is a middle school strategy where the teachers graphically organize their units. I'll leave it at that. And he said that has helped him understand the TEKS better because it's made him, kind of in a routine go through and dig through it and think about it in different ways in different contexts. And that's what good lessons are based on.
Okay. So we have, I've made notes on here to change this to the rate of change of position. And, did you have a question?
For later, I guess.
Okay, all right, and, with students, just a little aside, I wouldn't do this initially. So these concepts, with y'all, I didn't engage you with anything else, so it should not have been this way. I mean, I should have changed this to the rate of change of position. With other students, with little people or younger people, I would have done given them other experiences so that they had these concepts to be familiar with these words ahead of time. But we've changed this, we'll ditch that, and we're using, for the motion of the dog, positive direction and negative direction. Yes?
So on the table, we should be showing positive 0.5 of a meter change, positive.
Right, that's a great
And
point.
then, in the delta, right? Or on both?
Like
The
a
delta X?
like a positive 0.5.
Yeah.
Yes.
Okay.
And then for E through, I guess E through H, it should be
-1.
negative 1 meter. So my question I have is.
No.
Okay. I'll quit.
No, it's still positive 1 because his position is still positive 1.
In the delta X. you said.
Oh, on the delta X?
Yes.
Yes, that's
It
negative.
should be
Okay. So my question is negative velocity only possible in this circumstance where you have, I guess, a forward backwards directionality? Because if you had the 4 cardinal directions, it would be northeast.
I don't know, let's explore.
Okay. Oh, I'm sorry.
Hang
I'll wait.
on a second. On position F, or point F, for the position, would you have a positive or a negative?
Okay, well, let's see where he was at position F. In 5 seconds, he was at position 1.
1.
Right here on my number line, that is a positive number.
Okay.
So that's a positive position. Because this is the 0 mark on our number line. And then here's
But
the
it-
negative.
But
position.
between E and F, it is a negative change.
Change.
Mm-hmm.
Right. Right here. So these two